All right, so let us proceed to our first discussion. I will share the screen and go with my things. I use couple of things, so you will be able to enjoy this. You see my presentation slide?
Yes, sir.
Okay. Whenever you feel like you can stop me and ask questions, and my target is to actually talk about, practically, I'll be talking about, especially BI. This is my target is to talk about business intelligence. So let's proceed to our discussion is that the learning objectives that we practically in this discussion, once we finish, we talk about the difference between BI, analytics, business intelligence analytics, data marts, and big data. So they are actually connected, but we want to understand the difference between them. So business intelligence very widely used now, and artificial intelligence as part of the business, and then analytics. Then what we also have objective of this discussion is that we need to define the characteristics. Characteristics of what? Characteristics of data. Why? Because we want to make a good decision making. Because what happens is that ultimately what happens? We are doing big data, we are doing data analytics, we are doing business intelligence, we are doing predictive analytics, whatever it is. The ultimate target is actually decision making. And this decision making, if your characteristics of the data is not predetermined, then your decision is also kind of a wild decision, may not be good, may not be very correct. In some cases, it may be disaster. So characteristics of data for good decision making is very, very important. And then describe what data mining. Data mining, I already talked in the last, discussions, but I still want to talk on the whiteboard and talk about something. So that's, I was also giving an example of market basket and cluster analysis, but just to review. So let's proceed with this. Any discussions you feel like asking questions, you can, go ahead and ask questions. Now, couple of terms we have here is business analytics, business intelligence, big data, data mining. What is the difference? Look at it. First of all, the business analytics, it's a tools to explore past data to gain insight into future business decision. Business analytics means you are actually doing analysis and tactics. We sometimes don't understand why analytics, how the analytics is derived. Analytics is derived from two words, analysis and tactics. So analysis tactics actually helps to understand the trend of the past data, and based on that trend we try to understand what is going to happen in the future. But yes, of course, it is a probability. It is not absolute, but still you can have some kind of prediction. When we look at BI and business analysis, you see tools and techniques, it is only tools. But we are talking about intelligence. That means you're far beyond the tools. To turn data into meaningful information. That means BI is actually generating an output which is a meaningful information. But analytics is tools. So BI needs actually business analytics as part of generating this meaningful information. And finally, you all know that big data means we are talking about so large a data set, so complex in compared to traditional data sets. And mining is, of course, tools for discovering pattern in large data. As I was telling you that discover knowledge from the data. Any questions that comes in your mind? You have to say yes, no, and then I can proceed actually.
Yes, no
Any,
question, sir.
no question, right? No
Yes.
question, right?
Yes, sir.
Okay. So, oh yeah, what's the question?
Sir, no
Oh, no
question.
question. Yes, okay. I was trying to understand that if maybe you may have a question, so let's proceed then. And then talking about the business, you know, needs supports for decision making. Why business needs supports for decision making? That's the question mark. And if you look at it, uncertain economics, why we don't know, rapidly changing environment. Globally, business is very, very fast changing trends. So it's very natural to expect something of different order. Just to admit, our colleague here. So what happens is, global competition is another reasons for particularly this business and demanding customers because you really want business to grow as fast as possible. So taking advantage of information acquired by companies is a critical success factor, of course. So it is very normal. We understand that it is very usual that why we want decision making process in the business. Yeah. And if we proceed further from here, we see that what happens, the characteristics, as I was telling you, that the characteristics of the data for good decision making. Look at this, very important. Better quality data characteristics is first of all accuracy. Accuracy actually drives the core facts of the data. Just a minute, because someone is trying to join. Let me join him. All right, so accurate enough for intended purpose. You know what happens? The challenge lies here sometimes. Why? Because the domain is so vulnerable. Let me admit on. Domain is so vulnerable that accuracy of the data is difficult to determine sometimes. See, capture close to the point of activity. Okay. Uh, Capture close to this point of activity is one thing, and make accuracy compromise. Make accuracy compromises clear. Okay. Now, that means accuracy is a very important characteristics. The second characteristics is validity. Validity, why? Because there is a compliance with requirement, application definition, consistency over time, consistency with others. Just to make you clear, validity ensures actually one very important characteristic because the data is, if the data is invalid, the decision process will be compromised. So validity naturally is a very important characteristics of the data. The third characteristics, if we say, is the reliability. Reliability, collection processes constitute over time, multiple collection point between collection systems. There are different system data is coming from. And it's very important that data is reliable. Acha, can you give me an example of a reliable data? Anyone?
Suppose if you are doing a thesis or research,
Hmm.
we want the information from reliable source. Otherwise, if the website or the page is not reliable,
Hmm.
we cannot put in our thesis paper
True.
as a
But
reference.
I want to know, I'm interested to know that an example of a reliable source. You just mentioned reliable source. For example, can you cite an example?
Yes, like suppose Khan Academy is a renowned
Good.
page.
Yes. And you are taking some references from Khan Academy.
Yes.
Okay, I just have a complimentary question a minute, just to get someone join us. The complimentary question is very interesting. For example, can you tell, since you are really looking into it, what is the characteristics of a reliable data? Reliability has certain characteristics. What is that? I say something is very reliable. Your friend is very reliable. Suppose,
Yeah, it's like trustworthy.
Yes, trustworthy. What is that? Trustworthy means there is a characteristic. What is that?
It's like it has proven to be honest, truthful over the
What
time.
is that characteristics of honesty?
It means it's true to me and it's proven.
What is that
And
characteristics of true to me? It's very interesting question I'm asking you actually. I have the answer, but I wanted to see whether you can.
Sir, can I tell, sir?
Yes, please.
Sir, I think reliable data is means when I collected data from a source,
Hmm.
it should be same if I collected this data from another source. I'm I'm telling that.
That is
Suppose I
good.
collected
I
data.
think both of you answered is very close.
Yes,
Never
yes, sir.
changes with time. It
Yes,
never
sir.
changes with time. That means suppose you buy a refrigerator, you say, oh, my refrigerator is very reliable. Why? Because when I turn on, the refrigerator is on. So it's very reliable. So reliability means your friend is very reliable. Why? Because he's very trustworthy. Why? He's very honest. Why? Because he never changes with time. So reliability actually is a very, very important, guys. That means you get a data and then you see next time this is different. That means it is not reliable. Suppose you are measuring temperature and you buy a thermometer and temperature, you have a very high fever. You see that it is 104 degree one time and then suddenly very high fever, but it is 99 showing. It is not reliable. You understand now? It's consistent, right? It is all along same over the time.
Sir, I have a question, sir.
Yes, please.
Sir, there are some numerical data like the count of count of human, count of populations,
Hmm.
count of some disease statistic. That data can change with time.
Yes, but I'm talking about, let's say, when I say in 2nd January 2022, the total population of the world at the time of 5 o'clock in the morning was this. It will not change.
Got it, sir.
Because, it's actually bound to a time. You understand that. Everything is bound to a time. So if I consider the same time and if I get a different data, it is not reliable. You get my point now. Yeah, very good question actually. The fourth characteristics is actually timeliness. You see, the timeliness is a very important characteristics of data for good decision making. Why? Because this actually influence the decision because capture quickly after the event and available quickly enough, available frequently enough. So timeliness of the data is a very important characteristic because when we want to make something real time decision making, the timeliness of the data plays a very vital role. And we face a lot of challenge. Why? Because real-time analytics, I cannot compromise with the processing power. I cannot compromise with the, storage. I cannot compromise with the memory. Whatever is, the real-time analytics is always very, very expensive and very difficult to attain. The fifth characteristics is relevance. You see, the data must be, relevant to intended purpose because this is a challenge where we sometimes face that I have a plan to apply a particular, data analytics, but I'm not getting the right data. So relevance plays a very vital role because the decision lies based on certain set of data, certain features. Those features must be available. And last but not the least is that completeness. Completeness, you can understand that monitor quality to match the data needs missing data, invalid data, incomplete data. Completeness of the data is also very important. I was looking at an article, I was reading a paper, I was looking at, I was just, not to share you exactly how this proposal is submitted. I was evaluating a proposal yesterday. I was in the morning submitted by an associate professor of another university to a very respected organization for funding. But the title of this project I'm sharing with you because this is a big data project. The project is on classification of uh, rumors. You understand rumors comes from the tweet data. You remember, right? Tweets. There
yes,
are a lot
sir.
of rumors. Huh? So the project is on classification. I'm giving you idea why because there you can take up similar kind of projects and also in the future you get a lot of funding support. classification of prediction of rumors, it's actually more like rumors. You want to validate whether the rumors is right or wrong. So the project is on tweet data. Based on tweet data, they are going to come up with a algorithm or maybe methodology they will apply to see the rumors are right, rumors are wrong or right. You are classifying rumors based on tweet data. So this is a kind of data where you have a completeness issue. Why? Because when you suppose you are using Tweet API, I will also give you a source of looking at all kinds of APIs to get big data. And I was gathered about 20 different sources by which you can actually have APIs to get big data so that you can have a very good project. I will share that in the classroom. So you understand that characteristics of data is a very vital thing in the entire process of our life. This data is nothing but your water in your life. You cannot live without water. You cannot live without data in good decision making. So this is where we have these very important 6 characteristics. Like we started with accuracy, validity, reliability, timeliness, relevance, and completeness. Any questions that comes in your mind at this hour? Any other questions of anyone?
No, sir.
Yeah, it's okay.
No,
Wonderful.
sir.
Yeah, wonderful. So let's proceed. It's going. So information gap. Yeah, information gap is something is always there. What is that shortfall? What you are gathering and what you are using in the decision making. Why? Why? Because this is a very challenging part that you always have information gap. Information gap is very natural, number one, because we imagine there are still, if we say that we have, we generally call them legacy. Legacy system, if you say, that means I'm talking about, system, let's take yellow, system which is in 90s. Those systems, imagine, has a lot of data. But if you want to apply business analytics or data analytics or business intelligence, you really won't be able to apply. Why? Because there is an information gap. Information gap, why? Because you have a certain requirement in the decision making process, but the data that you have is not sufficient enough. So a lot of historical data are actually getting outdated. We cannot use them despite they have data value, but we cannot use them. Why? Because it is not the way the time demands. The data are different. So firms have inadequate data warehouse. That is one reason that you don't have data warehouse. You understand that data storage, it was very expensive even 5 years back. Now it has come to a very reasonable stand. But data warehouse, why you don't see data warehouse? Because imagine I give you a very interesting information. Many of you will agree, or maybe you can have questions. You understand that business continuity and disaster recovery, these two terms, we say BC, DR. BC means business continuity, DR means disaster recovery. You do understand that all banks, corporate banks, if we talk about banks, every bank has data center. Now, this data center, one is in the corporate office. Definitely they have BCDR. BCDR means another place geographically at least 10 kilometers from the corporate house, having same data center running to ensure that during disruption, business will continue. But the problem is, what is the problem? Can you tell me what I was about to say? What these banks are facing as a problem? Anyone? Any idea? Are you able to understand what I'm saying? That every commercial bank they have data center, but business continuity and disaster recovery is actually another data center, which is at least 10 kilometers distant from the geographically distant location, or they have also data centers. But as I was telling you that commercial banks and all those having this data center, they are in actually they cannot actually affords. So what they're doing? Any idea? Do you understand what they're doing?
Maybe, sir, they are using another, I mean, services to store their data, something like that.
No, actually, let me explain. You understand that data center. You have a data center. Let's say you have a data center at Gulshan. In Gulshan, there are at least many data centers. You're not supposed to know, but these data centers they have a BCDR site, maybe in Jessore. Jessore, Sheikh Hasina Software Technology Park, STPL. Now, this is from Gulshan to Jessore. There is a BCDR site, but what happens? These commercial banks they are having very tough funding because you have a setup in Jessore which is running, but it is not actually giving any service. It's an infrastructure which is not giving service right now, but it will be ready when there is a disaster. So it is actually very, very expensive. You understand what I'm saying? You have one infrastructure at your place you are using, another infrastructure is lying down 10 kilometers far from your present site, and you are not using that. So what happens? Many of the banks they are using BCDR site to give other services. You understand? To optimize the investment. This is a big investment actually. So
So what
BCDR,
kind of services?
yes. So you understand that information gap. The reason why it is happening, there are many pros and cons, but one very important reason is that the infrastructure is very, very expensive. So, there is that's why you see inadequate data warehouse. You understand that now. And business analysts spend 2 days a week gathering, instead of performing analysis, because data, you can understand that it's the average, analyst needs a lot of data. So almost data collection takes huge time. And then you come into business intelligence seeks to bridge the information gap. So business intelligence ultimately help to find the gap between the present, whatever you're gathering and what is needed for decision making. Huh? So let us proceed to further discussion here from here. So data mining, when it comes to this discussion, as you understand, that it is interdisciplinary. First of all, interdisciplinary. Why? Because you're talking about computer science and statistics. You are actually talking about manipulating data. So computational process, when we say data mining is a computational process. Why? Because you want to discover a pattern which is hidden inside large data set. And that's actually you incorporate different techniques like artificial intelligence, machine learning, statistics, database. So practically we have four things here. One is the database, and then this is actually we have to get joined with us. And this is your database. Then you have AI, machine learning. This is ML, machine learning, and then you have stat. All together, ultimately, is coming into this is also AI, and that's actually DM. So data mining means you're talking about multidiscipline. That's why we say interdisciplinary subfield. We have database because data mining needs data, so that comes from the database. You have data mining. Mining needs actually, I will actually go on to board now to talk about one specific methodology related to data mining. It was actually in the last class pending questions. Huh? And then we have statistics. Why? Because we do apply mathematics to understand the pattern. And ultimately, output is intelligence. So that's why artificial intelligence. So what you do in examining large data set to produce new information, uses statistical method and AI to analyze data and find hidden feature of the data that were not known. As I was giving an example of, shopping cart and those product items. And we are actually talking about, especially association rule mining. Any question at this particular slide? Do you have any questions here?
No, sir.
No questions. Okay, wonderful. Just to, let me know so that I can be very, comfortable. When we talk about business intelligence, it's actually more about intelligence and tools, because intelligence and business, you can understand that you are actually going to come up with intelligence. So you need techniques. And of course, there are tools. What it does is it turns the data into meaningful information. So what happens? There are two things. One is process and product. Process, it are actually a set of methods that you are actually using to organize the data into knowledge. So you can understand the transition is from data to knowledge. That means you're applying certain techniques to understand DG, to understand that what actually is the knowledge out of the data. And then product is information that allows business to make decisions. So when actually you're developing product, that's actually using this process. And this process is helping to develop the knowledge base. That means it's something like this. For example, you're doing BI, and the BI output actually is KB. KB is actually your knowledge base. KB means knowledge base. But this BI actually you're applying on data. So data to BI to KB, and actually ultimately your application is here. Your application is interacting with this KB, knowledge base. So that's how actually business intelligence works today. And you can understand that in business intelligence, today's corporate banks are actually, they are trying to retain customers. They are trying to make more profit from customers. They are trying to understand the customer trends using business intelligence. Any question at this particular slide you have?
No, sir.
Okay. But when you hear, you will understand that the difference between, can you tell me, I just want to understand. Can you tell me the difference between data mining and business intelligence?
Sir, data mining means collecting knowledge and information from any kind of data, but business intelligence means only working with the data or getting information and knowledge uh, connected to the business. Maybe.
Let us hear from others also. Thank you. And let's
Yes,
let me listen. Yes, please.
data mining actually means to find a pattern, meaningful pattern
Mhm.
from a big amount of data, and business intelligence is actually refers to using that meaningful pattern to make decisions, informed decisions.
Good, actually. Yes, exactly. Mane, you understand now. That means business intelligence has data mining inside,
Yes.
because you need to create this. You see, when I show you the data to knowledge base, you are actually having DM here. And the whole thing is, we call it BI, because business intelligence is using this knowledge base to make a decision. So process actually is DM, and product is actually output of business intelligence. Any other questions? Is it okay? Now we can proceed.
Yes, sir.
Okay. So let's proceed. And you take a look at this BI applications, customer analytics, human capital productivity analysis. business productivity analytics, sales channel analytics. You see, now these are all applications. You see, supply chain analytics, behavioral analytics. This is very, very important. Supply chain and behavioral analytics. But they are truly application of BI. That means what you have to do, you have to have a data. Then what you do DM, and then you have what? Knowledge base, and then you have actually BI. Is that clear, Manay? Does it make sense?
Yes, sir.
This is actually your part of the process, and this is your product. This is very important. Sometimes you will see that people don't understand the difference between data mining and BI. That's very, very important. So let's proceed. We can actually see much more here. So we can see now that what is actually business intelligence. Collecting and refining information from many sources, internal, external, analyzing and presenting that information in useful way, like dashboard and visualization, so that people can make better decisions. This help build and retain competitive advantage. That means you can continuously track, understand the pattern, and since there is a visualization, that helps you to make the decisions. We can proceed from here. Now, there is one example. This is a sample marketing dashboard. It's very well known, Clickfolio. Clickfolio is practically a dashboard which shows different trends. You can see here, it's a marketing dashboard. Marketing dashboard, why? Because you want to make a decision of marketing. You can see that leads in the month, then new customers, you can see your hits in Twitter, Facebook, Google Plus, LinkedIn, and then email sent. So you can actually make a tentative projection of your, market and present market and the future upcoming market. So this is a kind of a dashboard which actually is coming. That means what you see in the dashboard is a presentation. But at the back of this dashboard, there is a data mining, and then there is a business intelligence applied, and that's what you see as a summary on the dashboard. Is that clear? Any question to me on this? So when you see a dashboard, you see that there are multiple layers at the back. At the bottom layer is the data, and the immediate next to the bottom layer is actually data mining, and then your knowledge base, and then your actually business intelligence. Any question? No question, right? It's clear, right?
Yes, sir.
Yes. Let's proceed because we are actually making a. There is another one which is very interesting. It's called Fitbit. You know, it's a health dashboard. Maybe many of you are using Fitbit, and you see that it has a health dashboard. Why? Because you can have a statistics of your different activities. What are the steps you have taken, and then how many floors you have climbed, miles traveled, calories burned. So you can see your present trends, and ultimately this health dashboard. The decision is yours, of course. System may also recommend that if it is a recommended system will definitely recommend that you always see Samsung Health. This says that you have this much to reach to your target. So there is a recommendation coming, and that's actually in the form of business intelligence. So business intelligence, we are actually living with business intelligence today. We cannot ignore the fact that we cannot live. Actually, we are completely, emblazed with business intelligence. All right, so let's proceed. We know these examples already. All right, so I think somehow I get back to the previous part. Okay, I think I'm back to normal. It is going up, or okay, data mining, I think it's going up. Just to ensure that we are on the right direction, let me see. Yeah, so BI initiatives, if you see here, what happens in the BI initiatives, 70% of the senior executive reports that analytics will be important, competitive advantage. Someone is trying to join, so let me. join him. All right, so, and only 2% feels that they have achieved. Well, see, interestingly, no, let me go back. Only 2% feel that they have achieved competitive advantage. This is the international reporting that actually what happens, it is pretty new still now. 70 to 80% of the BI project fail because of poor communication and not understanding what to ask. It is in the year 2000. Of course, it's much better now. 60 to 70% of BI projects fail because of technology culture and lack of infrastructure. Is earlier. So it is quite improved now. You can understand that UCB, to my knowledge, is the first bank in the country to introduce BI, United Commercial Banks Limited, and they actually started BI back in the year 2016. They started, so it's quite mature now. BI practically is getting used, but as I'm saying, it is entirely new, lot of new learning. We need also corporate people to have data mining understanding and business intelligence knowledge. That's very, very important, actually. So if you see that evolution of BI, we look at competitive advantage versus analytics maturity. Raw data, you see what happened so far. This is actually sense and respond. This is predict and act. And there are two boundaries. One boundary we're talking about sense and respond, and the other boundary. If you see here, from raw data to clean data to standard report, ad hoc report, this is actually I'm talking about till 2010. And then generic predictive analytics started. Sometimes it started sometimes in 2010 onward. And then you are gradually talking about predictive modeling and optimization. But you can understand, so far, raw data is still raw data. Cleaning is a process we need to do. These two are actually implemented now. When we have a standard reporting. But generic predictive analytics, why did it happen? Because there is a market growth that actually you need to have a more prediction than ever, and that leads to actually predictive modeling. Predictive modeling, why? Because you are trying to reach out to your market threats, you are trying to overcome and make better productivity. And you know what happens in the entire evolution of BI, this optimization is a continuous process. What is best that could happen? Optimization, why? Because sometimes I need to cut down the cost of operation to make more profit. So cutting down operation, same happens in optimization. We are trying to minimize time for having better prediction. That means I'm talking about real-time analytics. Real-time analytics is only possible if you optimize. What I mean by optimize is you try to see where more time is taken by the process, try to reduce the time. So when you are trying to reduce time, when you are trying to reduce resource, you are actually optimizing. Any question on this particular slide?
Sir, can you repeat the last sentence again?
Yes.
Like, what are by minimizing time? What are we trying to achieve here?
You see, optimization is a very important term. I just want to tell you here. Optimization, we have two aspects. One is time. Second is resource. Time and resource. I'm talking about whenever we talk about optimization. Let's say you're doing some task. I'm saying, please optimize. That means I'm talking about that you try to reduce time, try to reduce resource consumption. You see? You understand now? Because resource consumption, why? Because if you can reduce resource consumption, that means you are increasing the productivity. If you are reducing the time, that means you're increasing the productivity. Optimization targets to better productivity, higher productivity. All of us actually, we are doing optimization. We try to reduce time and try to reduce resource consumption. Does it answer your query?
So is it like efficiency type?
Yes, of course. Efficiency and productivity, they are actually hand in hand. Absolutely. You are trying to increase the efficiency.
Yes, sir. Got it.
Yeah. Yeah.
Thank
So
you.
what happens, you see, predictive modeling and then optimization. Why? Because when you are predicting something and then you understand now I can predict. So now fine tune parameters so that it takes less time, it takes less resource, if possible, to generate better result. So that's actually, it's a continuous journey. Optimization never ends because as with the time, when you're optimizing, something is optimized, suddenly new technology will come and you have to optimize it again. So optimization is a kind of a journey like excellence. Just a minute, let me join in. So it's a very interesting scenario we discuss here, and then go from here to you see evolution of BI. Another slide just to discuss a little bit. You see, you can see the trends here. You see the year, as I was telling you, the vendor revolution, 1990, then 2000, 2007, BI goes mainstream from 2007. And if you take a look at this from client server, web, this is software as a service, web service, mobile, cloud. And if you take a look at the upper, get the data, that is data warehouse, use the data, business intelligence, optimize performance, performance management, and drive processes, analytics. So if you see, look at each kind of, these arrowheads are coming up with different technologies. You can see here from hardware to grids to virtualization, multi-core, RAM, SSD. SSD, you can understand that this is actually very compact, high performance storage. Same goes with this is actually with the hardware. Hardware scaled up. Why? Because we have to have a competitive advantage of software hardware. They are kind of a husband wife. They cannot live without each other. DBMS database, you see SMP, MPP, DW applications scale up, all scale out, all in one, in database analytics, analytic platform, Hadoop. Hadoop is actually ultimately introduced by the year 2011-12. And it's actually by Google, so we will be actually doing also Hadoop. If you take a look at, this is actually ETL tools. ETL tools, you can understand that electronic transactions, how it happens. ETL engine came up, then ETL EDC real time, data intelligence, all in one DI platform, data virtualization service, then cloud BI. That means all the services are running in the cloud. If you take a look at the first one, BI tools, OLAP came in 92, 93, OLAP came, then web-based business intelligence, then interactive reports, it's a low-cost BI, dashboards, then your virtual analysis, self-service, mobile BI, cloud BI, and search BI. So this is actually BI is embedded in the cloud now. That means what we see as a whole, a vertical of high performance analytics. You see, high performance. But we are talking about the year 2016 onwards. So any question that comes in your mind looking at this? So you can understand the timeline and the development of different services and technologies. But if you see here, the trend actually is going upward, and at some time you will actually reach to quantum process, where it will not be, it will be very hard to optimize it further. Why? Because optimization also has a limit. You cannot optimize to fine granular level. It's not possible. So you get the data, use the data, and optimize, and finally drive processes. So this is actually how the BI is still evolving. So we are expecting that there will be a kind of IoT enabled BI, which will actually, because the device that you see in hardware, you don't see any IoT here. So IoT is going to come absolutely, and there will be a different business intelligence, of course. Any question? Shall I proceed?
No questions.
We can proceed, huh?
Yes, sir.
Okay, thank you. We'll proceed then. Now, talking about data warehouse, it's something new, so take a look at it very carefully. Data warehouse is actually, it's 1996, 97 collection of data from multiple sources, internal and external. You can see what happens in this particular warehouse. You have ETL from ERP, Enterprise Resource Planning. You have a marketing software, data is coming. These are all electronic transactions, HR, sales, all data are coming into data warehouse. And data warehouse, actually, you're generating data mart. So historical operations, summary, all these are coming. Data cleaning before use, of course, is stored independently from operational data, broken down into data marts for use. Data marts are more like, actually, it's like a data dashboard. Data for a specific purpose. That's actually data mart. So data warehouse, actually, today in most of the organizations are having data warehouse in the cloud. Why? Because people are trying to have alternate resources available, and of course at the scalability is very, very important. Remember this term. I just want to ensure you whether you understand this scalability. Do you understand scalability?
Yes, sir.
Can you cite an example for others so that if you want?
Scalability means we can scale it up or down based on our demand.
And can you give a practical example, like
Something like on cloud computing, we have used this term very much, and we can scale up our bandwidth or disk space and other resources as much as we need.
Very good. Anyone else?
Sir, can I?
Yes, please.
Sir, the very good example of scalable is, sir, the services we take from cloud. As suppose Google Drive. When we use 10 GB, after that Google will provide us another 10 GB and increase the storage in the server. Or if we say the scalability, it is Amazon cloud services like S3 database, which can be scalable at any time. 10 GB, 12 GB, 14 GB, 16 GB,
Okay.
or scalable can be any cloud services or any services we take from the internet, like storage services, bandwidth services. Whenever we need to increase the service increases. Or we can tell about the Facebook, Google. They give services to several thousands of people.
Thank you. Very, very nice. Very nice. Who else want to add? But I want a practical, real life example.
So as far I remember, while we were doing cloud, it was like pay as you go tag. It was like you can pay as much as you use. You don't have to use your own devices. You're getting in cloud.
Okay.
So I think these are the things.
I just want a little bit.
can I?
Yes, please. This is a very
Sir,
important terminology. Actually, I'm going to tell you that. Yes.
So we are currently working in AMD server, actually AMD graphics. So when we are working, suddenly when our service is up, then we need more codes. We are using remote computer. So we propose our requirement, then they put it up.
Okay.
Then when our service is low, our demand is low, then they put it down.
Okay.
Like this.
All right. So.
Yeah.
Anyone else? I'm going to show you a picture. It's something very interesting. But anyone else like to add one more? Anyone like just to say about scalability differently?
Sir, it can be example a delivery package delivery. When we have 10 product, we will use one truck. When we have 20 product, we will use 20 truck. The product increase, the truck have to be increased. The product will decrease, the truck will be decreased.
Fantastic. Okay. So let me tell you a little differently, because all of you are very nicely answered. For example, this is a road. I'm drawing a road. and you are in a car, you're driving a car. Baby time we draw this kind of car, right? You're driving at 60 kilometer per hour in this road. It is, let's say, you're driving at this time is, let me put the time here on the top. You're driving at 5, yeah, I think it's okay. You're driving at 5 a.m. in the morning, 60 kilometer. And this road is now full of, car, lot of car. It is now 12 p.m. and you're still driving 60 kilometers per hour. That means you have the same speed at whatever is the traffic. This is actually high traffic, you see? Does it make sense? This is low traffic, but your speed never suffers because it is highly scalable. When there is no traffic, you're driving, whatever speed you're driving, you drive at the same speed when there is a very high traffic. So speed never suffers. So the network is highly scalable. That means as you grow, your automatic bandwidth is automatically increasing and decreasing based on the number of traffic. And the network is always, well, the scalability plays a very vital role in web applications and cloud applications. Because why? Because people are connecting to cloud. You cannot wait. Let's say now 5 customers are requesting a service and they are getting in fraction of nanosecond. And when there's a 50,000 customer, they get the same service at the same time. You get my point now?
So it's like consistency.
Yes, it's scalable. That means if one client is requesting a service, get the service in 10 seconds. If there are 10,000 clients requesting the same service, every client gets 10-second service. You have to ensure that. That is actually scalability. That means the scalability is very vital when you are using SaaS model. I'm talking about software as a service model. Scalability is the heart. That is very, very important. Very nice. Okay, I appreciate all of you have a good thoughts. All right, so there are 5 tasks actually happens. I will give you a break for about, let's say, 5 minutes. Is it okay? Or 10 minutes?
10 minutes, it's okay, sir.
10 minutes. So I think we go to break right here. Then we can actually, I can stop here. And I will stop the recording and then I record back again. Let's talk about this 5 tasks. And the 5 tasks, the first task that you see is classification. Very common data mining task, categorizing data into actionable. For example, loan applicants, maybe defaulter or not defaulter. We can have classification is a very important area of data mining. And there are well-known algorithms like decision tree and, date base, and so on. There are many algorithms which works for classification. The second category of task is very important is estimation. Estimation means we are talking about actually more like prediction, like response rates, probability of responses. Estimation is based on actually classification. Classification is categorizing data, but here you are actually estimating the response rate. It's more like sometimes we call it's basically regression. Sometimes we call actually regression analysis. And regression analysis actually is a part of estimation process. We have the third task, which is very important, is prediction. Prediction happens why? Because prediction, like we are talking about predicting customer behavior, and sometimes we call it unsupervised learning, like clustering. So prediction is a very important type data mining task. Affinity grouping means we are talking about, as you remember in the last class, we were discussing about, find the items which are close to each other. More like what items or services are customers likely to purchase together. Affinity grouping is more like association rule mining, finding the association between the items. And last but not the least is description, finding interesting patterns. So we basically have these 5 common tasks in data mining. But practically, we sometimes say that data mining, we basically have, uh, you know, um, 2 different types of learning. We say supervised one, and then unsupervised, and the third one is association rule mining. So basically, we have 3 different types of data mining algorithms. Unsupervised learning. This is actually learning. Supervised learning, unsupervised learning, and association rule mining. So any question that you may have in this particular area? Do you have any questions? No, because I'm shocked. Kintu, what my plan in the coming class is more hands-on, and more experimental discussions. আমাদের টিম আপ একটা হচ্ছে প্রজেক্ট টিম আপ, প্রজেক্ট ডেলিভারেবলস প্ল্যান করে ফেলা, প্রজেক্টের টাইপিক্যাল প্রজেক্ট ডিসকাশন করা, and hands-on tools. I want to demonstrate many things. So let us proceed to the next then. As you see, data mining techniques, we have market basket analysis, cluster analysis. Cluster analysis means we are talking about unsupervised learning. We have decision tree and rules induction is actually supervised learning. Unsupervised and supervised learning, the difference is that unsupervised learning, we don't see, we learn. And supervised learning means we see and learn. So the difference is two different learning. And neural network is actually pattern recognition. So we basically have this particular application of data mining. Any question in this area? This is actually your association. That's why I did not write here. It is actually association mining. So we basically have association mining, unsupervised learning, supervised learning, and pattern recognition. That's actually part of the data mining techniques. Any questions? Do you have any questions here? No, right?
No, sir.
Okay. অনেক কিছু আমাদের দেখার সুযোগ হবে. Talking about market basket analysis, as you see, find pattern or sequence in a way that people purchase products. এটা আমরা দেখেছি commonly all recommender system. Recommender system is very popular, and recommender system actually practically uses concept of finding patterns. That means association rule mining. এটা কিন্তু practically example of association rule mining. Recommender system uses, and আমরা দেখেছি যে Walmart and Netflix, people who buy gin also buy tonic. And those kind of obvious and non-obvious thing. Your Amazon to all eBay to all online, except for Bangladeshi online portals, there is a still not very strong association in rule implementation in e-commerce portal of Bangladesh. So there is a big possibility that you can take up a project for e-commerce in Bangladesh to implement actually this market basket analysis, which is very important. They can have a recommender system implemented into the e-commerce portal, which helps people buying more actually. So the people more buy means we are having better business. Let's proceed. If there is no question, we proceed to the next is the cluster analysis, which is what we say it is unsupervised. unsupervised learning. And unsupervised learning, you see what happens, grouping data into like cluster based on specific attribute. Unsupervised, why? Because we learn without looking at it, without understanding. But of course, we have a mathematical basis. We have certain mathematics to apply to cluster them. So, like for example, crime map clusters to better deploy police. That means police are radically, they may be in science lab and on a particular date and a particular moment, because of the system is suggesting that there must be a possibility the crime rate will be high. So, it's actually helping decision making. How to build a cellular tower and the outbreak of gigabytes and so on. I mean, I'm talking about Corona now. So, practically, cluster analysis plays a very vital role, especially in web engineering. Web engineering, I'm talking about web documentation, surfing. Cluster analysis plays a very vital role. We can actually have understanding a surfing pattern of a particular user based on cluster analysis. So we can actually group user to understand their specific pattern, but using unsupervised learning scheme. That's actually cluster analysis. Talking from this point is almost in the summary now. So what we talked about so far is the BI, analytics, data marts, big data. We define the characteristics of data for good decision making and then describe data mining in detail. We talked about a little bit. I'm going to show you, demonstrate you data mining in the next class physically. I will show you many items, explain and examples. So far we are done on this part of the discussion. Any question that comes in your mind?
Sir, how is it different, data mining and neural pattern?
Okay, very good
The
question.
word,
Okay.
yes.
What happens in let me take that question. Okay, let's finish here because then we can go into new discussion. Data mining happens to be data to knowledge. That is it, data mining, as simple as that. But when it comes to your when it comes to neural network, you see now what I'm showing you. Neural network is input pattern and that leads to an output pattern. But
Okay, so
there is no question of knowledge. It's actually pattern recognition.
when we input pattern in a neural network, this pattern comes from data mining, right?
This pattern may comes from data mining, yes.
Okay. Okay, sir.
Because
Understood.
data mining may help to generate that pattern that you
Yes.
feed into neural network to recognize something. Very good
Okay, sir.
question. Very good question. Any
Thank
other
you.
questions you have?
No, sir.
Very nice. So I think we can stop the sharing. We can go into another discussion now. I'm going to show you something. All right. So let's proceed to